This next lecture is going to be more general, not exactly about sound waves, but just about in waves in general. There's another phenomena with waves that's called interference we need to study. So interference is when we have two or more waves interact with each other and they interfere with each other. And we can actually see this interference with a change in amplitude. If you look at a body of water, you'll see waves going up and down. So you see these little crests and troughs, but it's actually a complicated system of crests and troughs of a number of different waves all added together at once. So the interference that waves undergo, it's either constructive, this is the interference when it's above the rest level, or it's destructive where it's below. And when we look at a body of water, you'll see points where the water is above the rest level and points where it's below, and constantly changing as more waves come in and out. So let's observe this interference looking at just one or two waves at a time. It'll be a bit easier to understand. And let's talk about what wave interference is at the particle level. So you already know that waves are a result of particle vibrations, and that the particles in the medium are connected by forces that behave like small springs. So when the two waves meet, the forces of their particles are added together. So this is better understood by looking actually at this slide first. And what we see is a waveform in A and another waveform that are moving towards each other, and two waveforms in B that are moving towards each other. In A, we have a rectangular waveform that's above the rest position, and we have a triangular waveform that's below. And for B, we have two semicircular or elliptical waveforms that are both above the rest position. When those waveforms meet, we have what's called a superposition occur, and that's where we add together the two waveforms, and our result is something like this. In the first case, when we add those together, we're essentially cutting a triangular half out of the waveform that was moving to the right for A, and for B, we add the waveforms together, and those the two waveforms in the center add together to have a larger amplitude. And then later the waves move on after the pulses. They just kind of continue along their way, and they've passed through each other. And nothing has changed about the waves after they pass through each other. Their wavelength, their frequency, and their amplitude all stay the same. So this is the concept of superposition. So write this down. And again, interference is what happens when we have two or more waves where the particles and again, interference is when we have two waves that act on the same particles of a medium, and it could be constructive or destructive. So let's look at constructive interference. If we have two waves of the same amplitude and wavelength, and they meet at two crests, we have a supercrest created. Same thing, but if they meet where they have two troughs, we have a supertrough created. Those are periods of constructive interference, because when we add them together, we have an amplitude greater than what the original amplitude is. Even though one is a trough and it's below the rest position, it's still constructive interference. Keep that in mind. So constructive interference occurs when we have either a supercrest or a supertrough. A new wave with a larger amplitude is created. Destructive interference is when we have waves that almost cancel each other out. So we have two or more waves that are out of phase, and they combine when we have a crest and a trough at the same time. So a crest meets a trough. In that case, our resultant amplitude is less. So this occurs when we have a crest or a trough meet, or a crest and a trough meet. Sometimes if they're of the same amplitude, we have what's called a node created, where we're actually at our rest position. Constructive and destructive interference occurs for longitudinal waves as well, so it happens with sound waves also. So here it says, state whether the interference is constructive or destructive. A large crest meets a small trough. Well, if we have a crest meeting a trough, that's destructive. If we have a super trough happen, that's constructive, because we've added them together to make a larger amplitude. A compression meets a compression, that's constructive. What happens when two billiard balls rolling toward one another collide head-on? They would rebound backwards from the collision, because those are physical particles. That's how particles behave when they collide. But with waves, waves don't collide, but when waves interact, they go through each other, because it's energy, and energy doesn't have a physical collision. One way to use this information is through the use of sound canceling headphones. So what sound canceling headphones do is they detect a sound, a waveform that's occurring that's undesired to the listener, outside of the listener's headphones, and they basically invert the they use a signal, an electrical signal, that inverts the sound wave and then adds the inverted sound wave to the outside source. So what you would actually hear would be the interference of the electronically generated sound wave and the sound wave outside the headphones. Adding those two together reduces the amplitude of the outside sound source, and essentially we have a canceled sound, or a near canceled sound. So you can write that down. One of the uses of interference is through the development of noise canceling headphones.